Welcome to Montgomery Public Schools Virtual Enrichment Program. My name is McDade and I will be your Physical Science 8 teacher.
This is the Alabama Course of Study 8.17 Standard. These are the objectives for Alabama Course of Study 8.17. Materials needed for today's lesson: notebook paper and pencils. Brainstorm to make a list of waves. Your list may include types of waves or technology that uses waves. You have 5 minutes to complete this task.
Waves are rhythmic disturbances that carry energy without carrying matter. There are two types of waves: mechanical waves, which are waves that need matter or sometimes referred to as a medium to transfer energy, and electromagnetic waves, which do not need matter to transfer energy. There are two types of mechanical waves. The first type of mechanical wave is a transverse wave. In a transverse wave, energy causes the matter in the medium to move up and down or back and forth at right angles to the direction the wave travels. Longitudinal waves is a mechanical wave in which matter in the medium moves forward and backward along the same direction that the wave travels. An example of a transverse wave is wave in water. An example of longitudinal waves would be sound waves. If you look at the picture of the transverse waves, there are two main parts: the crest, which is the top of the wave, and the trough, which is at the bottom of the wave. The distance between crest to crest or trough to trough is the wavelength. Longitudinal waves have main parts: compression and rarefaction. The compression is the part of the wave that is compressed tightly together, and the rarefaction is the part that is spaced out. Electromagnetic waves are waves that do not need matter to transfer energy. Examples of electromagnetic waves are radiation, TV and radio waves, X-rays, microwaves, lasers, energy from the sun, and visible light. Electromagnetic waves travel as transverse waves, meaning that they have crests and troughs. Let's watch this video to get a better understanding of waves.
Waves transfer energy from one place to another. You should already know how to describe them in terms of frequency, wavelength, and amplitude, which we looked at in another video. In this video, we're going to look at two ways they can be classified. Waves are produced as a result of vibrations and can be classified as transverse or longitudinal. Whether they are transverse or longitudinal depends upon how the particles are made to vibrate as the energy passes. Let's look at longitudinal first. This is where the particles vibrate parallel to the direction in which the wave of energy is travelling. Notice that the ends of the slinky don't ever leave the hands holding them. It's only the energy that travels. The places where the coils or particles are bunched together are called compressions. Where they are furthest apart are called rarefactions. An example of longitudinal waves is sound. When a drum is struck, the drum skin vibrates, which causes the air particles next to it to vibrate. This causes the next air particle to vibrate, then the next, and so on until the vibration reaches the ear, causing the eardrum to vibrate. The vibrating air speeds away from the source, creating a sound wave. Let's look at another type of wave, transverse waves. The hand moves up and down, as does the slinky, but the wave itself moves from left to right. So the particles vibrate at 90 degrees to the direction that the energy is moving. We can simply think of it as, in longitudinal waves, the hand pulses horizontally, pushing and pulling, and the wave energy also moves horizontally, back and forward. Whereas in transverse waves, the hand moves up and down, but the wave energy still moves horizontally. Again, the ends of the slinky never leave the hands holding it. It's just the energy that moves along. Transverse waves are usually used to show the wavelength and amplitude. The waves on the surface of water are transverse waves. They make the water surface go up and down. All types of electromagnetic waves, like visible light, are also transverse waves. So, now you should be able to describe the differences between transverse waves and longitudinal waves. Remember, it is the energy and not the slinky itself that travels.
Let's review. Label each part of the wave. How did you do? If you correctly labeled the crest, the trough, the wavelength, and the transverse wave, you're correct. If you correctly identified the wavelength, compression, and rarefaction of the longitudinal wave, you are correct. This concludes our lesson for today.